All right, everybody. Thank you for coming. Let's get started. So I'm Nicolas Robert. I'm a software team leader for KD, for 4D, development team. So today I'm going to talk about testing. I'm going to talk about how we do testing within 4D, how we test our own application, and what are the tools we are providing to you guys in order to test your own 4D applications. So I know that testing is not a very exciting topic, especially when you're a software engineer. But I think that's something that kind of we all struggle with, and something we should probably be better at. So how do we test 4D? Well, first of all, before I start, actually, I have a couple of questions. So who in here actually writes unit test? All right. So actually, that's pretty good sometimes. And who here uses source control? All right. Okay. So testing is tricky because you can spend a lot of time and money writing tests and still have bugs at the end of the day. Okay. Also, you need to find the right balance between testing and the time and the money you spend in testing versus developing new features. And of course, this balance varies. If let's say you're developing a 4D application to manage your wine collection, or if you're writing software to land a spaceship on the moon. All right, different quality level you want to achieve. Of course, it depends on the type of wine you drink. If you drink very expensive wine, then you have to be pretty sure about your testing there as well. But so first, how we do testing at 4D. So no matter what is your the quality of level of quality you're trying to achieve, no matter what, you want to get the best return on investment. Okay. For whatever money you're putting in writing software and testing your application, you want to get as many bugs as possible. Okay. So before our releases, so we used to have 6 months of specification. That was a traditional waterfall or V-cycle. I don't know if some of you guys came to my session with Caroline, where we talked about our releases, but we talked a little bit about that as well. 6 months of development, 6 months of test. So, of course, our quality department was kind of taking over, I would say, like alpha grade software. It's kind of working, but not really, with the right moon and sort of on the right, system. Usually the developer system is always working. Outside, usually we tend to, have bugs and crash. Now with the new, hourly cycle, I'm really trying to put more responsibilities on my developers, so they actually, deliver something that's, is almost production ready. To do that, they have to, write more tests. So I want to make sure that whatever they developed or they're developing meets the functional contract. Okay. But first, they're supposed to develop, what we ask them to develop. Okay. Step 1, and make sure that whatever they are developing is actually very good in quality. And now with our release cycle, QA is taking over like a far more, robust software. We call like a beta plus. I wouldn't say it's, maybe not production ready, but that's pretty close, right? And also we kind of change our point of view. Now our quality team, again, at 4D, between 6 and half a dozen and dozen, engineers testing 4D, always, every day. So we kind of see them now more as an independent audit service, because we're, putting more responsibility on the developer to actually do the testing. And QA always is super important, as always. But it's more like more like independent audit service. So that's the testing pyramid. On the right, you can see like implementation cost. So that's kind of what it's supposed to look like if you have like, a well-balanced, testing environment. At the top, you have UI testing. Okay, so often those tests are very brittle. They break easily because they depend, heavily on, they go through the user interface. Every time you like change, the size of a button, or you move something, or the test is probably going to break. Okay, you can actually automate UI testing. You have tools, like FrogLogic, Selenium for the web, or like Squish for C++ applications. You can simulate, user interactions. Click here, do that, take a screenshot. Is my screenshot, compared to what I have in my database, matching. But that's pretty expensive to put in place. And every time you change something, you have to change the screenshot or change your script. So another way is to test your application at the level right below. Right? So you get rid of the UI and you attack your application directly at service layer or API level. That's what we call like behavior testing or service testing. You can do that, of course, only if from the start you put like your UI logic separated from your business logic. Okay, and you have to do that by design. It's better to do it, from the start. Once it's done, it's kind of heavy on refactoring and try to separate those two. So when you develop, as much as possible, you should separate UI and service and like behavior code, business. And at the end, you have unit testing. Unit testing are very easy to write. Should be pretty fast. Often they're very easy to automate. There's no UI involved. So of course, you're not testing everything with UI testing. Okay. You can't really simulate, user inputs, but at least you can make sure that the foundation of your application is sound. Unit testing, they can break pretty easily as well. Every time you do refactoring, it's going to break. You're going to break some unit tests. That's what you want. You want your unit test to break to tell you, okay, whatever you did, it's not working anymore. So you need to fix the unit tests and to make it work again. But because they're very inexpensive to write, that's all right. So unit testing. So what does it bring? So first of all, unit testing will help you to detect regressions as early as possible. The more you wait to detect a bug, the more it's going to cost you. Okay. The best way is to you write a couple of lines of code, you run a unit test. Oops, I broke something. Then you can fix it right away. Okay. While your mind is still, in whatever you're doing. The more you wait, you have to go back to your code. Some code you wrote like maybe a couple of weeks or even a couple of months or even years ago. It's always like, it takes a while to get back into it, okay? So early regression, that's super important. Also, if you have a bunch of unit tests, usually you have a pretty good, idea of the maturity of your code, of your development. If you know that you did a lot of refactoring and you have like 50% of your unit tests passing, you know that you still have like a long way to go before you can go into production. Okay, and without unit testing, you don't have this feedback to tell you, okay, I'm pretty good. Usually it's like you like that, like I'm feeling like almost ready, but you're not sure. So unit testing actually gave you data to really make like to make the right decision. And also it helps the developer to take responsibility of the code. Like before, we used to have our developers writing code, and as soon as the code was done, send it to quality and start something else. They were kind of waiting for quality to get back to them and say like, well, actually what you're developing is not what we were expecting, for example. That's always a waste of time and money. So I really want my developers, 4D developers, to feel responsible for the quality of their code. So what's critical to success when you want to put in place a unit testing strategy? So first of all, modularity. So you need to separate, UI from, business logic. Like I said earlier, you need to be able to maintain your unit test at a pretty low cost, because unit tests are very useful to detect regressions. But if you're spending a lot of time to write unit tests and repair unit tests instead of writing new code, then there's really no point, right? So you need to find a way to make sure that you can quickly update unit test, make it work again, okay? And of course, automatic execution, because unit tests sitting on your desk, and by desk I mean like desktop on your computer, it doesn't bring you anything. Okay, so we created a unit test, and it was working at the time. If you don't run it every time you make a change, there is no point. Okay, like every time you change something, automatically you should run all the unit tests you have to get this feedback you need. And after reporting, so when you have like big teams, by big teams I mean like more than one, you need to have pretty good reporting tools. It only takes 2 developers before they start blaming each other for you did that or no you did it. So by putting in place a good reporting tool, you can actually when something breaks, you can send an alert to the right guy and let him know that whatever you committed like an hour ago broke the unit test A, B, C line 26 whatever. This test is not working anymore. Okay. Of course, you don't want to nag developers by sending reminders every hour, because what's going to happen is pretty clear. If you use Outlook, they're going to create a rule saying that whatever comes from my unit test bot, I'm going to put it in this folder and I'm never going to look at it again. Okay? So again, that's the right balance between enough information but not too much information. So what had to be done? Yep. So that's a tricky one. I believe that was Hercules, 14th labor. We don't talk about it that much because that was not the most popular one, but that was pretty hard to do. Actually, I kind of tricked them. I made them believe that they were actually already doing it. That wasn't true, really. No 40 developers in a room. Right, good. So I kind of lied to them a bit. When a developer writes, let's say I have a developer working on a list box. Usually at 40, every developer has like a specialty, well, more than one, but a couple of specialties. Let's say one guy is in charge of a list box. So on his desktop, he has like pretty big database with a bunch of tests. His own personal test that he runs every time he makes a modification to the list box. Often this database is not really automated. We create some user inputs, but the tests, all the tests are already written there. So all you have to do is actually transform this kind of manual, database into a unit test. Okay, so it's really about capitalizing tests that our developers were already doing. And of course, we need to integrate our unit tests with our source control. Okay, so I know that not all of you guys are using a source control. That's fine. I know it's not very easy to do with a 40, but as a C++ developer, it's actually a bit easier to do. And for us to investigate what happened to a unit test using source control is very, very powerful. Okay, you can go back, see what changed, who did it, why, stuff like that. And of course, like I said, we need to automatically execute a unit test. Then we had to create a tool to monitor the execution. Start the execution every time someone made a change, and send a report to the developer. Not too many, just enough. Just poke him once in a while, but no nagging. So how it is being used at 40? Every time we release, or every time we work on a new feature in our release cycle, the developer also writes a unit test. Okay, that's mandatory, right? We're not shipping anything. Actually, we're not even activating a feature in our release, even in beta mode, if the unit test is not done and passing and successful. Also, we execute our unit tests, on a daily basis. Like I said, that's mandatory. Of course, we also need, on top of the unit test, we need a stamp from our quality department to make sure, okay, good to go. So what are the tools that we're actually providing to you guys and stuff we're using internally to write unit test? Well, we have the ASSERT and log event. So I'm not going to talk, for like an hour. I actually have some demos. I'm going to try to make this interesting. Maybe at some point I will pretend to have some technical difficulties, maybe a crash or something, to keep things, interesting. So an ASSERT are actually very powerful. We tend to overlook them and not really use them like we should. An ASSERT is pretty much always true unless you have a bug in your code. You shouldn't be using ASSERT for condition testing, okay? But if you have some condition, that, let's say this pointer should never be null, or this value should never be above, 5, then you put it in an ASSERT. Because you know that if this happens, something wrong in your code, it's probably a bug, and after who knows what can happen. Maybe later you're gonna have some memory corruption, data corruption. You can have a crash 10 minutes later. So you might as well just stop the execution of your application right now. While you know that's something wrong, at least you have the ASSERT saying okay, this condition is wrong, is false. You stop it, and then you can try to understand what happened. Okay, it's at some point you need to cut your losses, right? Like in Las Vegas, you bet too much money, you bet your car and your house, at some point you have to stop, cut your losses. So that's kind of the same with an ASSERT. If you look at GCC and LLVM, actually they have GCC is 9,000 ASSERTs and LLVM 13,000. And I'm talking about production code, okay? Even NASA uses ASSERTs in a cruising phase. But not in landing, of course, because in landing, you just want to land, no matter what. So even if, something wrong happens, at least you're going to try to land, on the moon, on Mars, right? But for, other phases like, cruising, for example, they do use ASSERTs, okay? So that's an old command, nothing new there, but just wanted to talk about it because it's actually important, and that's a key to our unit test, strategy. And also log event. You can log event. That's very powerful to understand, what's happening in your code. And after you can actually test your log file by parsing and trying to make sure that a specific line is in there, okay? Especially when you're trying to test, a UI. It's kind of hard to, pop up a display and, make sure that the right information is on screen, but by just logging a bunch of information on a log file, and by after parsing it, parsing the log file, you can make sure that your execution path went the right way. So application log is parameter 79, and you have also set ASSERT enabled. You can activate or deactivate all of the ASSERTs in your code in just one line. Quick demo. Oops. Here you go. All right. Okay, so here I'm going to activate diagnostic log, activate debug log. I'm going to apply a filter to the debug log. Okay, I just want to display. I just want to log calls made to the ASSERT command. Of course, I'm going to activate the ASSERT, which is actually activated by default. I just wanted to show you the command. And here I have my ASSERT, and I'm going to log an event. So if I play this, all right. So everybody knows that A is actually a car of 65. All right, and I'm going to continue here. All right, so here in my log file, I have 4 lines, and you can see it right here, this one. I have assert false, okay? So actually I have the information that something went wrong. And if you look at log file here, you have like hello assert, all right? So that's information you can use in your test to see like, is actually my assert, true or false? Did I get, this specific information in my log file, all right? Another command that was created internally, that's a new command that you guys can use, okay? But we had to do it, I believe, to be able to open automatically unit tests, execute them. Okay, so that's very easy. It's open a database. You just give a path to a 4DB file, and it's going to open this file in 4D. It's going to replace a current database and open this one instead. So I'm not opening a new 4D. That's within the same 4D application. It's like doing close application, open application, browse, get this one, file path. Okay. Export structure. So again, the goal being to be able to, export our unit test to our source, source control tool. We had to be able to export, the database structure to a file so we can actually make comparisons, between version A and version B. And to do that, we implemented the export structure command, passing the text variable. And what it's going to do is going to populate this variable with the database structure definition as an XML format. So that was already in 4D. I believe you could do like file export, but now you can do it, using a command. Okay, you can analyze, the XML file, do some comparisons and stuff like that. Okay. And of course, like the sister command, twin command is import structure. Same concept. I'm going to read a database structure from a text variable and create, all the tables and fields that are defined in there. Okay, I have a demo for that. So export, okay, that's super easy. So, all right, that's it. I'm going to get my delete me, not now. All right. Okay, well, that's, of course, I don't have any structure in my database, but you have some basic information about the database. So now I'm going back there. I'm going to do structure. All right. Okay, so you see. And that's, I think you guys know already this formatting. That's nothing new. We just made this information available from the 4D language. And we have also, oops. Also, we have the import. All right. So I'm going to read a database, a structure definition defined in this file. I'm going to import it. All right. And now I'm going to structure, import a table. So let's say I'm going to do that, and I'm going to do Control-C, Control-V. Oh. Sorry. All right. Okay, so I can copy tables. That's nothing new again. Okay. In this case, you see, when I do it through the database editor, 4D sees that the table with the name table 1 already exists. So I'm going to prefix copy of. However, if I run the same command again, in this case, I'm getting an error. Okay, because when you do it by programming, then we consider that it is your job to make sure that since you can export the current structure, you can import it, you can export it first, see what's in there, before importing, and you can actually prevent collisions. We didn't want, by using import structure, we didn't want 40 to make decisions for you by renaming a table, copy of. So that's the only difference. But when you do copy and paste, from a structure editor to like a notepad, you're going to get the exact same data. Another difference when you import, the UUID defined in XML text you're importing are going to end up being different in a database. Okay, the name, everything remains the same, but 40 is going to recreate a new table, so those tables will have a new unique ID. Okay. So you can't really compare when you do an export. You can't really compare exactly the two files. You need to actually do some. I'm going to show you how to do it properly. So unit test component. Okay, so now we put in place everything we needed. Open command, import, export, the use of asserts, the logging. Now it was time for us to create our unit test component. So that's very easy. 40.unittest, 40 base, and it's a component. So you just put it in a component folder. Okay. So to be able to use this component, so you have so far. Now we have quite a few restrictions, but the code you need to test should be in a component. Right? For now, you can't really using our component test, directly methods from a currently open database. We can, however, test, components. But if your, code is pretty modular, you have like different components, then you're going to be okay. It works best when combined with a source control, but you don't have to. It just, since we're exporting everything to text, like, structure, the code as well, as you will see, we're going to export, all the unit test code that you have to define in, 40 methods into a text file. Then it works best, if you combine it with a source control, but you don't have to. So how does it work? So you create a new database. You implement a new method. That the method should start with a test underscore. I'm going to explain to you why. You're going to execute the component unit test method called unit prepare. You have to do that only once. And then you do execute all. So by doing execute all, you're going to look for all the methods that start with test underscore and execute them. That's the only reason why you need to have like something that starts with a test underscore. That's it, right? And then you're going to do an export. So 40, the component is going to prompt you to enter some information. Basic one, description, a developer. So the right guy actually gets the email. So you're supposed to enter an email address here. And after you can select what you want to export. Structure, data, eventually resources. And by resources, it means everything that's currently in a resources folder. So whatever file you have in there, we're going to export it. I'm going to show you guys exactly what I mean by export. I think it's not really clear for some of you guys. I can see some faces. So let me. So I have like some kind of a dummy database. Let me sure. All right. Actually, you see here, I'm going to do open database, by the way. So I'm going to. All right, so I'm simply opening my dummy database. In here, I have a couple of methods. I have a test import and test using log file. So this is pretty much what a unit test should look like. So you're going to write that method is actually testing my import method. That's actually the unit test I wrote when I developed export-import structure, because I was a developer for that. Since it's mandatory, and I'm also a team leader, so I don't have a choice. I really have to do it. I wrote a unit test for it, and that's part of it. I wrote like many tests. So what I do is I export the structure definition to a text variable. And after I'm going to parse it using DOM, for the commands. Okay, I'm going to look at, do I have a table called table1? If not, my assert is going to pop up an error. I'm going to say, okay, that's wrong. And after, do I have like a field named name of type non-null, of type, 4 should be like, UUID. It is unique, with a hello increment and so on. So I'm testing all those parameters to make sure that my command is not actually forgetting anything, okay? So every time I make a modification, me or someone else to the code actually managing the export, we run a unit test. And if at some point we stop, exporting, I don't know, specific information, like a description of a table, then we're going to get an alert. I'm going to receive an email saying like, okay, something's broken. And also you can write tests using log files. So that can be pretty powerful to use when you write unit tests. What you can do when you're supposed to go through a specific path in your application execution path, you can write a bunch of log, like some labels, some information, and after you can parse the log file and make sure everything is in there in the right order. So for example, in this case, I'm going to clear the log file. I'm going to generate, that's just a dummy command to generate some information, write some information in log file. And after I'm going to make sure that my helper method called unit log match is going to find hello unit test. Right. So maybe you don't believe me, so maybe if I change hello to hello. All right, okay. I cannot find this string in my log file. So that's a very simplistic example, but you can do something like much more powerful. You can say, all right, I want to make sure that between this log and that log, I have 5 times this log, or no more than 3, or at least 12. All right. You can really start having some pretty complex testing scenario just by using log files. And it also means you can pop up windows, crowd them, it doesn't matter. You don't need user interactions. You can write something like before displaying a dialog or label, and writing another log file when the dialog is being closed by programming, for example. So of course in this case testing everything, all the layers from user interface to like the bottom layers of your application. But you're testing almost everything, like 90%. Okay, except for the UI part, you can test everything. And it's better to test 90% than 0, right? So, sorry, I'm not done with my demo. All right, so I have my unit test. Okay, so first, step 1, I'm going to do a unit prepare. All right, I have some warning. Oh, this component is going to create some additional databases for you. Some additional methods. And now if I look at execute, I have a new one is execute all. I do execute. All right, so you're going to see that I have 2 commands. I start with test underscore. See, like the generate event is not in the list, okay? Because by convention, it's not supposed to be executed. Did I fix my hello world? No, I did not. Classic. Oops. Thank you, unit test. I have a bug in my code. All right. Sorry, I have some issues with the trackpad. It's a bit sticky. Oh, damn it. Right. All right, so everything has been executed. And now I'm going to export my unit test. This is when it gets interesting. On the desktop, dummy unit tests. Please remember the name if I don't. All right. Developer. So I'm going to blame someone else just in case it doesn't work out. Don't tell anybody. All right, structure. So let's look at desktop now. Dummy-tests.unit. Can you guys see it? Okay, in here I have my unit.json, JSON file. Nice. All right. It's pretty much everything that I had to enter in my export dialog, description, email and stuff like that. Very basic. Structure. Okay, that's a table I've created. All right, and method. So here you can see I exported to a text format. The code, and you can see. All right, that's the code. The same code, right? To a text format. So now if I go back here, I'm going to close my unit test. I'm gonna now. Okay, I have unit test, but it's not a 4D database anymore. It's just like a bunch of files on my desktop. Okay, so I need to import it. So I'm going to do database from a unit test definition. By the way, this is going to change. Right now I'm doing it from the toolbar. It might be directly from the menu. I'm working on it. I didn't have time to submit as a code because I didn't have time to finish my unit test. So okay, I'm going to go there, unit JSON. All right, and here you go. That's the same, same code, same unit test, structure definition, everything in there. Okay. So by doing that, I can write unit test, export it. I can have my, my robot to automatically have, like, let's say I have a directory with a bunch of unit tests. That's what we do. We do like everything in the same directory in our source control. And we have a 4D application that's going to go through, like, for each unit test is going to import it, execute it, close it, look at the log file, and send an email to the guy if something went wrong, which would never happen. So, all right. So now I'm going to do that. I'm going to create some data. All right. I'm going to do save. So now I just added some data to my database. So I'm going to do another export. You see, this information is already there, so I can just update the description. I don't have to re-enter everything. I'm going to check data. Okay. And here I have my SQL export with my data. You can also find a new directory called build. That's a temporary directory, because what we do, there's no magic, right? We still have to create a database for the database. So we have like a template, an empty template. We're going to open this template, import all the code, the structure, and use this as a unit test. We can run it. And we're going to put it in a build directory. But this one is going to be replaced and deleted every time I do export, import, export. So never make a change, in that one. Okay, that's a standard for the database, but that one is going to be deleted every time you do an import. So don't make any change there. Okay, you import the database, you change your code, you export it. Some helper methods to help you, write unit tests. So that's the very beginning. We are probably going to improve it, but at least for starter, you can start and stop the logs. All right, You can do it by using the right parameters and all, so nothing fancy about it. You can clear the log, do a unit log match. Okay, like I said, you can think of many other fancy way to use the log files. Between this one and this one, make sure you have like 5 of that one. That's stuff that can be written in a near future, maybe some next R release. Unit prepare only once, unit export, and unit execute all. All right. So okay, that's nice, but I guess you guys don't want to spend time testing 40 application. You want to spend time testing your own application. I mean, you're welcome if you decide to write unit test for 40, please do. But I'm sure you have your own bugs to fix. So like I said, first of all, you need to test a component. So let's say you're, I'm going to, okay, so like I said earlier, we need to start from scratch. I'm going to create a brand new database. So let's say you're like a regular expression guru. You just love it. You use it like everywhere. So we decided to create a component for it. So you have your own regular expression component. And you use this component in all of your 40 applications. Okay? So you want to test it, especially regular expressions. Are you guys using regex? Do you guys know what I'm talking about? Yeah? You heard about it? Just make sure it's on my accent. I don't think that's some fancy French dish or something. All right. Regular expression. So if I go to regex, all right. That's a component developed by Vincent Delachaux, the guy who did also, 40 pop. All right. So I'm just using this component. So, well, step one, I'm going to create a new method, which will start with. Yes, thank you. Regex extract. Well, I'm pretty, actually, I suck at regex. I'm really bad at it. So I have some kind of a cheat, cheat sheet right here. I'm going here. Oops. Nicolas. All right, that's just some 40 code. I'm going to copy it. All right. Okay, that's my unit test. Okay, so I want to make sure that I'm providing this component to all of my clients. I want to make sure it's really it's perfect, no bugs, because I really rely on it. So I'm gonna. That's a target. That's just a simple text. I'm going to use this to write test. So first, I'm going to make sure that I can extract like phone numbers, right? So I have a phone number here. I think that's Jack's borrower phone number. It's really hard to reach though, always busy. After you have like an IP address, I want to make sure I can extract an IP address from my text. So you see I have a trick here. So Obama IP address is this one, and this is not a valid IP address, right? So I want to make sure that I extract the first one, not the second one. All right? And also I want to make sure that I can extract phone numbers and emails. I'm going to play. All right. So nothing happened. Maybe I'm faking it. No, it's a demo. Maybe I have no bugs. So let's see. I'm going to go do that. All right. So if you look at it, IP address. All right. So I'm going to do yes, I have only one element. So I was able to extract the correctly formed IP address and not the other one. So that's a success. Same for phone number. All right, phone number. I got Jack Bauer, personally made and professionally made. We just hired the guy. Very efficient. And he worked like 24 hours. That's crazy. So, all right. Okay. I think that's it. I mean, you could spend like hours and days literally writing tests about regex. That's not the point. All right. So you wanna transform this database into a unit test. Okay. So you're gonna do a unit prepare. All right. How many times do you have to do that? Thank you. Who said twice? All right. Okay. And I'm gonna do executor just in case. Oh, classic mistake. I forgot a breakpoint. So, of course, when you have a bot running automatically of the unit test, you have a breakpoint. It doesn't look good. Actually, what we do for that, because it happens, we have one of the parameters in a JSON file is a timeout. And let's say I put like 5 minutes. If the unit test doesn't return after 5 minutes, the bot is going to kill it and mark the unit test as passed, saying that, okay, timeout. Failed, timeout, all right, as a security. So I'm going to remove the, do you have more? Okay, fine. All right.
What was the error that you had before?
It is just a warning saying that everything has been executed. Okay. Everything, can you read it? All selected methods have been executed. Means it's good. I have ASSERT enabled, and I put like all the tests are in asserts, right? So if something goes wrong, something will pop up. We have an option to actually make the assert silent and redirect everything into a log file when we do it automatically. All right, so now if I go to my desktop, you guys remember where I put my unit test? I hate it always happened to me. All right. I didn't export it. Did I export it? This one is working, so I'm going to take responsibility for it. All right. It's right here. Okay. And here again you have method. So this time I did not export the structure. I have the same JSON file and the code and the structure. I didn't export the data. I don't have any data. When you can, all right, I think I'm going to wrap up. When you can, when you write unit tests, it's often better to, I wouldn't say it's better, but it's just as good to either import data or just generate data on the fly. It really depends what you have to do. So unit test launcher, all right, so tests are useful only if they're executed. It's nice to have like a database with thousands of tests if they're never run, right? There's no point. So we have to make sure everything is run, executed, on a daily basis. And to do that, we developed a unit test launcher. This is still under development, so I don't have it here. I'm not going to do a demo of it, but it's pretty much what I said. It automatically creates, executes unit test that it reads from a source control tool. Okay, and I generate a status and I alert so the developer saying that something wrong. Just once, not 50 times. It's just enough. Okay, thank you. Any questions?